So already there are so many lectures available on YouTube, so many playlists available on YouTube for CFD. Then why again this new playlist I am making for CFD? So before going into the CFD and lecture series of CFD and all the contents what I am going to provide, introduction about that, just I want to introduce myself. It is very fascinating. My name is Vikas Kumar Srivastav. My students and my viewers call me Viru sir. I have my own coaching center, ConceptLibrary, and in ConceptLibrary we take care of IIT JEE and NEET exams, and I mean classes are running for that in offline mode. We have center in 4 cities, and other than that I take classes especially for GATE, aerospace engineering, and it's been 10 years I am teaching aerospace engineering students for GATE exam, especially for GATE exam. And other than that I was taking, like when I was involved into IIT JEE and NEET coaching, then in the beginning days I used to teach all the 3 subjects, then I dropped chemistry, then I was teaching physics and math, then I dropped mathematics, then for several years I was teaching physics. But currently, because I became so much busy with my startup Punk Aerospace and with ConceptLibrary GATE students and their queries and their doubts, so currently I have dropped physics. From last 2 years I am not taking physics as well, and now I am only focusing on GATE aerospace engineering. So here I am coming up with the new lecture series for CFD. So let's understand what was problem what were the problems I was facing during my CFD preparation when I was learning CFD, and here what are the things I am going to convey in all these CFD things. So first of all, see, there are something called, you may be aware, like dots. Okay, so when you will watch my lectures, then you will be able to connect all the dots. This was missing in many lecture series on YouTube, and if you have lack of time and you are watching any YouTube series, then you will not be able to find your doubt very fast. So you will be panic like, okay, any lecture series is not like satisfying on YouTube. But see, there are so many lecture series, they are actually satisfying on YouTube. And some teachers are really amazing, they have taught almost everything, but when I was going through their lectures, then there were some small points they were missing, or they did not explain, or they skipped, or they ignored, and they used to be the main points where students were facing main problem. Okay, when I was learning CFD, I was not able to connect my dots, like, okay, I am learning this. For example, there is something called TVD scheme. TVD scheme means total variation diminishing. So there are schemes. So I was not aware like why there is need of TVD scheme and what is this TVD scheme. Then for example, you will come to know that in the lecture there is Swabbe criteria. What is the need of Swabbe criteria? Okay, like story was not clear. In my case, story was not clear. Like, okay, what is the story? Like for example, if we know that displacement, then we know the velocity, then we know acceleration. Is there acceleration, then we have force. If force, then it can change your inertia. And what is inertia? Like we have a pattern when we learn physics in 11th and 12th class, right? So that kind of pattern I was missing when I was learning CFD. Okay, so being an IITian, it is my responsibility to crack concepts in small concepts so that students can understand things very well. Okay, so I promise you that you are going to learn CFD the way you actually looking to learn. So I am going to make CFD very good. Wow. See, I am not very good in CFD. First thing, I am not like it's not like I am PhD in CFD or something. But one thing I promise, I will make CFD very easy for you with entire background. Okay, so let's start this as a introduction part. What is CFD, why there is need of CFD, and what are the steps like on average we follow in CFD. Okay, so see here, when you will type something like what is CFD in ChatGPT, then ChatGPT will give you a different flow of learning CFD. When you will watch these YouTube lectures, then there you have so many so many channels, they have a proper playlist. In that playlist, many people, they will show you coding, many people they will teach you CFD, some people they will solve differential equations in CFD, blah things, but story is not clear. Like actually what is this subject? So come and understand like this. Actually what is CFD? See here, now I'm starting. Okay, understand this situation. Actually what we do in CFD, before going to that, you understand, suppose you have any formula. Okay, suppose this is my box. Suppose at this at this edge you have a particular temperature, suppose 100 degrees Celsius, and here you have 50 degrees Celsius. So if there is temperature difference, then heat will flow, right? Okay, so flow of heat means heat transfer. Okay, suppose another example. Suppose you have different height inclination here and you have different height. You pour water here, water will flow down. Okay, why? Because there is difference in altitude. Suppose this is a wire. Suppose this is the wire. At this point you have different voltage. At this point you have different voltage. Then electrons will flow. Because of that you will be getting current. Okay, means, and one more example. Suppose this is a flat plate. Over the flat plate air is flowing. Air is flowing. So if air is flowing, then air temperature and this wall temperature can be same or different. So now point is, if air is flowing, then with how much speed air is flowing, this is one thing. Now if air is having more temperature as compared to the wall temperature, then heat will transfer from air to the wall. Okay, so now just now I have explained some physical situations where some property is flowing. Okay, now those properties in different departments of engineering can be different. For example, in fluid mechanics, that property can be velocity, pressure. Maybe in solid mechanics, aircraft structure, strength of material. In these fields, design manufacturing fields, it can be stress, it can be strain. Like when you are bending a pipe, then at different points, how much stress you are getting, how much strain you are getting. So right now I am talking about some physical situations. Okay, this is one thing. So this became a dot. Okay, this became a dot. Now I will say you one more dot, then I will connect these dots. Okay, now you understand that. Suppose now, okay, I am coming to second dot. Suppose you have a partial differential equation. This now, see, this is totally new. Suddenly I change the topic. Now suppose you have partial differential equation and you want to solve that partial differential equation, then what will you do to solve the partial differential equation? So if you remember, when you were in 11th class, 12th class, in your intermediate, if you are in India we say intermediate, so then what we used to do, we used to follow some methods. Okay, so now you tell me, using those 11th class, 12th class methods of solving differential equation, can you solve any kind of differential equation? No, right? Okay, this is one thing. So we came up with the idea how to solve those kind of differential equations where some methods are not useful. I will come to that. There are certain differential equations. I will connect both dots, don't worry. There are certain differential equations. Those differential equations actually you cannot solve using ideas of like analytical ideas. We say analytical ideas. Like for example, separate the variables, right? There is one method, you remember, separate the variables, y this side, x this side, and solve the differential equation. Okay, so this is the second dot. Now come to the third dot. Third dot is, there is something called formula. Okay, now suppose I am giving you that at this point you have certain temperature, at this point you have certain temperature, different temperatures, and from here, so this is a 2D diagram. So suppose consider this point as the origin. So in this direction you consider y-axis, in this direction consider x-axis. So somewhere suppose there is Apple logo, right? So suppose I want to find that where I have Apple logo, at that Apple logo what will be my temperature. So I need a formula in which x location should come, so that I can find out x coordinate of this point, y location should come, and some constants and variables from physics like thermal expansion, those constants should come in my formula. And if this point is being affected because of this temperature and this temperature, then these two temperature values should also come in the formula. Then I can find out temperature at this Apple symbol. Okay, so suppose this point is P, then I can find out temperature at point P using these people. Okay, so I got a formula. So now let's connect the points. So before connecting the points, you should have one extra knowledge. That knowledge is, still our mathematics is not that developed. Our mathematicians are still working. There are some differential equations Okay, differential equation is of two types. One is ordinary differential equation, one is partial differential equation. Mostly in CFD, we deal with partial differential equation, but of course we also deal with ordinary differential equations. So we say in short PDE, partial differential equation, ODE, ordinary differential equation. Now see here, when I am conveying this knowledge to you, I am not following any source, I am not following any book or something. This is my own understanding, what I have understood. But understand this, to understand this idea, I have spent one complete semester, and in that one complete semester, when I was learning in the days, I could not understand this story. Slowly, because see, okay, just hold this part, understand this story. Suppose you have a river, you have to cross the river. So you have two ways. Either you swim over the river, over the surface of the water and you cross, or you sink and somehow you cross the river. So in my situation, I was not knowing how to swim. So I was sinking, and then I came to this side. So anyway, whether you swim or come, or you sink or come, you have to come this side. So somehow I completed my CFD course in IIT, IIT Dharwad, and but now during my coursework, I was referring books suggested by my professor, and I was also going through different playlists, okay, on YouTube. So what I have understood, that story I am going to convey here. Okay, so now come back to the story. I have a physical situation. That physical situation I want to see. For example, this is a beam. If I am bending the beam, okay, I am bending the beam, then beam became like this. This is visible to me by my eyes. But on every point, how much stress is being developed, that is not visible, right? So can there be any method that I can understand that at every point? When I am saying every point, we have infinite points in between, but for our simplicity, we will discretize these points into certain points. So only on those points we can analyze that. Okay, so now at certain points I want to find out that how much stress is being developed. So you cannot see using pen and paper. If you are finding out, then how many points are there? On every point you have to calculate stress and strain. If you have done your strength of material course or some other example also, you can consider that at every point you have to calculate that property, and it will take so much time, right? So if you are using CFD, concept of CFD, then using computer will do the work. Okay, I think I am going somewhat distracting you. Now come back again. You have a physical situation. So now see, actually we have a good thing. Any physical situation we can convert into a partial differential equation. Get my logic? Any physical situation you can convert into a differential equation. This is one thing. So I connected two dots. Okay, one dot was a physical situation, another dot is partial differential equation or differential equation. You can say ODE also, differential equation. So from physical situation, you will come to the ODE or PDE, right? Now, this physical situation, when you are converting into partial differential equation, here there is no problem. Why? Because in real life we have so many different physical situations, but when you are learning CFD in your UG or PG course, that time we are not at that much level that we can convert any physical situation into our differential equation. So during our learning period, we are given with a certain physical situation. Okay, and what are those popular certain physical situations? Convection, advection, conduction. These three are very popular physical situations. Okay, and whenever you are learning conduction, advection, convection, these kind of situations, you should know the examples of these things, like what is conduction, what is diffusion, what is advection. Okay, so actually in mathematics these terms are already converted into partial differential derivatives, like you will be having derivatives. So now I mean to say, we are given with a limited physical situation during our course. We are not given with any type of situation in our course. So first thing is clear that when you are learning CFD in your UG course or PG course, that time you are not given with any kind of physical situation. No, you will be given with a certain type of physical situation. For example, heat equation. There is something called heat equation. Heat equation has its own differential equation. So you don't have to derive the differential equation. Okay, you don't have to know that how this differential equation is coming. So you have a different heat equation, wave equation, right? Conduction equation, steady state convection diffusion, steady state advection diffusion, like these equations are already present, okay, for different physical situations. Okay, one thing is clear that you have a physical situation, and now that physical situation, for that situation you have a differential equation. Clear? So two dots connected. Again, you also understood that we are not going to understand all types of physical situation. Certain only certain. Now again, because I saw different books also. So when you are following different books, then in different books, to explain a particular concept, they have to take example. So they will take similar example. For example, if you are following Malala Shekhara book or Chung book, so to explain situation, they are going to pick heat equation, wave equation, Navier-Stokes equation, continuity equation, momentum equation. So when you are actually picking up these equations, so they will be in partial differential equation format. Those equations will be in partial differential equation format. Now I will come to the last part. Last part, I gave you one more dot, that was formula. Okay, actually in what happens in daily life, we solve our partial differential equation and we get a general algebraic equation, basic linear or non-linear we used to get, right? You remember in your 11th 12th class when we used to solve our differential equation, then in the answer we used to get our algebraic equation that can be linear or that can be non-linear, right? It depends what kind of partial differential equation we had, right, and which method you have used. So now I am saying actually there are some partial differential equations. Now see here, there is a catch point. There are some partial differential equations what you cannot solve using analytical method like variable separable or whatever methods, 7-8 methods, popular methods are there. You may be knowing Leibniz type of some equations you can solve, some equations you can't solve. Okay, you may be having idea that some people say that Navier-Stokes equation is one equation which is unsolved. Like people, they can't solve, it is difficult to solve. People are working on that. And I also heard that someone from China or from some other country, I'm so sorry if I'm wrong here, someone like recently before 1 or 2 years I came to know that someone solved Navier-Stokes equation using analytic method, something. Again, I'm sorry if this information is wrong. So it is in my memory, I have heard, it can be wrong also. So now idea is, suppose, sorry for the camera, suppose if someone is solving a particular differential equation, then it will look like a formula, it will look like a equation, linear equation. So in linear equation, like I said, that I need a formula in which formula some temperatures and some coefficient should be there, so I can find out temperature of any point. So when you solve actually a partial differential equation, so that you are doing means what, you are actually converting that differential equation into a formula format. So finally you will land in CFD. What we do in CFD, we solve those differential equations into a linear algebraic equation. In short, we say linear algebraic equation, LAE, linear algebraic, LAE. Okay, so we are going to get LAEs, plural LAEs we are going to get. It depends, because you will be solving so many equations, right, differential equations. So actually see, CFD is actually very easy at UG and PG level because you have very limited set of equations. So what is your first job? First of all, you mug up, means you memorize, you by heart some popular equations, Navier-Stokes equation, conduction equation, convection equation, advection, like these equations. Okay, for steady condition, for unsteady condition, how the these partial differential equations will change. Okay, this is the thing. So I hope you understand that you are not given with any type of physical situation. No, you have limited situations what you are going to learn in your UG PG. So that situation will be is already having a set of partial differential equations. So you got partial differential equation also. Now your job is how to add the concept of CFD to crack this equation as linear algebraic equation. So now I am going to explain how CFD works in this, how CFD helps you, and like here the main story I am going to convey. So I took roughly 19 minutes to explain this. I can see here. Okay, now this is part done. Okay, what is your problem statement and what is your final answer? Everything is clear now. Your final answer will come as a linear algebraic equation. In that, everything will be known, only one thing will be unknown. So that unknown you are going to find at a particular point, and coordinate of that point will be there in terms of xy. So if you want to find out the same property at different points, then you will change xy values and you are going to find out the same property at different points. But now now easiness is, you are not going to do this by your hand. In your exam you are only going to show the final answer as that LAE, linear algebraic equation. And when you do coding part, when you do CFD part in computer, then what do? You actually write down all the codes properly. That okay, you have a partial differential equation, that also you will write. Then how are you converting those steps? That CFD part I have not taught yet, I am about to discuss. So this part also you will code in that, and then finally you will come to your answer, that also you will code there. And after that in the coding itself, you will say to the computer that how many points you have. In those points you will mention coordinates and everything. Then you run, then the computer will give you results, that whatever points you have given from your side, on those points these are the values of your pressure, these are the values of your temperature, these are the values of your any scalar function. That scalar function in CFD we show by phi. Okay, phi. So mostly when you are learning CFD in any IITs or NITs or any college, then actually they use phi as the symbol of any scalar function. So I hope you understood this much. If this much is clear, and one more thing, if something is not clear, don't hesitate, you just give me your thing in comment box. I will find time for sure, definitely, but please put genuine doubts. Okay, because already I have lack of time, so I will be working on my next video of CFD. Okay, because when I will develop playlist, that should be a kind of a very general universal type of playlist. If student is following my playlist, they should not be bothering about anything else. Okay, and I will also tell you that in which book, what is the method they have used, in which book, so that it will be easy for you, which book is useful for you. And I will also tell you that in different playlist, in different YouTube channels, how other teachers or how others YouTubers they have taught this thing. Okay, now this much is clear. Now I am going to tell you that how in this story where CFD is coming, in this story where CFD is coming. So see guys, when you have a physical situation, for that you have your differential equation. Our job is to convert that differential equation as linear algebraic equation, and that linear algebraic equation will behave like a formula for us. For that unknown point we are going to calculate different properties here. Okay, in this CFD is coming. How CFD is coming in this? So see here, CFD means computational fluid dynamics. CFD is not any software, CFD is not any ANSYS or Fluent or something. I will explain everything, what is the meaning of this. CFD is a method, computational method in fluid dynamics. CFD is a method. What is the use of that method? Actually, when you apply that method, you can convert this partial differential equation into this thing, your linear algebraic equation. Okay, you got it? What is CFD? What CFD is doing here? Okay, I don't know how long this video will be. Please have patience and watch this video whenever you are free, because I am going to explain things you will feel better actually after understanding this. Okay, so after getting a partial differential equation, when you are starting your CFD course, then first you understand the physical situation what you have. In that physical situation you have two things. One is space or any metal or any wire or something like space or material, something you have. This is one thing. And next thing, you have the particular property what you are going to judge. Two things are there. In that space only, that property variation you are going to judge. For example, in this wire, you are going to judge that at these points, how the heat is flowing. So you got two things. One is the wire and one is the property. So in CFD, what do we do? Two types of discretization we do. What is the meaning of discretization? Breaking these real continuous space into discrete points. Okay. For example, when you have to go from one height to another height, okay, then you use ladder. Okay, you know, in some old village we used to use bamboo, two bamboos, and we used to add one bamboo on the way, and we used to go from one space to another space. It means what? From here to there space is continuous, but when you are following the steps, that is not continuous, that is discrete. So first thing is, you are going to discretize your space. That we say technically, we are going to discretize our domain. So one thing is discretize your space. So for that we have methods in CFD. Okay, how to discretize the domain or the space. Again, for that we have further concepts like walls are there, then in between one more layer is there. We have different names for that discretization. Okay, so when you are discretizing your space, this is one thing. And now to next thing is we have property also. So where is that property? For example, temperature. Where is that temperature? That temperature you will be having in convection diffusion equation or advection diffusion equation. In that equation, temperature term will come, right? So you need to pick a related equation, related partial differential equation, in which temperature is coming. So now we are going to discretize that particular equation. That differential equation we have, right? That also we are going to discretize. Now point is, two types of discretization you saw. One is for domain discretization, that is different thing. Okay, now I am keeping that aside. This thing I will not repeat again. Now you have the differential equation. That differential equation you are going to discretize. So when you discretize differential equation, here only we have three major ways to discretize a differential equation. Three major ways are there. Okay, now you see here. When you are discretizing a differential equation, then from here different fields of CFD will start. Okay, you are what kind of problem you have? You have a problem in fluid mechanics or thermodynamics, or you have a problem in strength of material. I mean, what kind of problem you are going to solve, what kind of differential equation you have. According to that, for example, if you have a stress-strain relationship, then it goes to that solid mechanics thing. You can say structure thing in different departments, civil, aerospace engineering, aeronautical engineering, automobile, mechanical. So that is different thing. Or you can say, suppose you have a flow equation, suppose you have continuity equation, that is also in differential form. So I mean to say that according to the branch of the engineering, we have different differential equations. Now that differential equation we have to discretize. Question comes, why we have to discretize? Then answer is, I told you, because these differential equations are difficult or impossible till now. Are either they are very difficult or they are kind of impossible to solve analytically, to reach their solution. In 11th class we used to solve differential equations, right? So we are going to use a technique. Now that technique, when you will apply, that is known as discretization technique. Using that technique, you are going to crack your differential equation and convert into linear differential equation. That's all, job over. So according to your differential equation, you are going to choose which method. So popular methods are finite difference method, FDM, finite volume method, FVM, finite what is another one, finite element method, FEM. Yeah, finite element method. So actually in my course, when I was doing CFD, I did not do finite element method, but I will learn and I will complete in this course. And then we did finite difference method and finite this thing, volume method. So you should know one more thing. In the beginning, finite difference method was developed to discretize the equation. Domain discretization I have left. I am only talking about the method. So actually, first of all, you have to choose that in which method you are going to discretize your particular differential equation. You are going to choose finite difference method or finite volume method or finite element method. Now again, there is a problem. every equation is not enough suitable to discretize using any method. No. So this is what the course of CFD. This is what the meaning of course of CFD. In course of CFD, you also learn these small important points, that this particular equation will be more easier if you are solving using a particular suitable method, FEM, FDM, FVM, which one you are going to apply. So suppose I am applying I have chosen a partial differential equation which belongs to a fluid course, thermodynamics course. Suppose Navier-Stokes equation, or leave it, suppose unsteady convection diffusion equation, unsteady convection diffusion equation. Okay, so now that equation I want to solve, I want to convert into linear algebraic equation, and I am using which method? Finite volume method. Okay, so using finite volume method I am going to convert that. Okay, this is one thing. So one thing is clear, that you should know what is finite difference method, finite volume method, and finite element method. Okay, it means what? Every CFD engineer will not go for every method. So from here domains are defined, like, okay, in which domain you are working as a CFD engineer. So you will say that I am working in fluid and thermal, so I am using finite volume method. Your friend will say that no, in future I have interest in structure, so I will work in finite element method, so I will learn finite element method. That's why every CFD student will not learn all the methods, but whoever is learning finite difference method, they will learn finite volume method for sure, because actually earlier it was finite difference method, then after further development they developed finite volume method, which is, you can say, upgraded version, but loosely I am saying, not exactly, loosely I am saying. So people are actually more comfortable in finite volume method, right? Finite difference method, finite difference method is also there, but finite volume method is also there. So it is, you can say, better version of that. Now in exam they also ask what is advantage of finite volume over finite difference. So you can do ChatGPT, or you can follow any book and you can get it. Okay, but these things I will definitely cover lecture by lecture. Here you understand now what is I want to give you all the dots, all the backgrounds I want to give you here. Okay, now when you are choosing finite volume method, then in finite volume method you are going to choose under that, suppose you have point A and point B. Point A you have, so come back to here. Suppose you have this space, here you have some temperature point A, here you have some temperature point B. Okay, now suppose here you have discretized, like cut point 1, point 2, point 3, point 4, or you can say P1, P2, P3, P4, all the points we have. Now I will choose any particular point. Suppose I am choosing point P. I have chosen, keep finite volume method I have chosen. So now I have chosen point P. At point P, I am going to apply finite volume method to calculate temperature, pressure, shear stress, or blah blah things at point P. So what will happen? That differential equation I am going to discretize using finite volume method to calculate property at point P. Which property? Any property. Currently I will show that property with phi. Is this clear? Now let me know if you have any doubt till here. So when you have a differential equation, you are using finite volume method. Now in that finite volume method you have steps that only you are going to learn in CFD course. Okay, like you are going to choose upwind method, or you are going to choose quick scheme, like quick method, upwind method. There are some methods, finite differencing scheme. So there are certain schemes you are going to use. Okay, means what? Once you have decided that you are going to use finite volume method, in that again you have to decide which scheme you are using. Now from where the concept of scheme is coming, so this is what you are going to learn in CFD. So like what is the role of scheme? So this is introduction thing, that's why I am not going to detail, video will be very lengthy otherwise. Already 33 minutes I have covered. So now in that scheme further you understand which scheme is stable and unstable. Okay, so why the stability concept is coming, I will tell you. Because whenever you will code, okay, whenever you will code, that code is made up, you are doing in computer. So we have some errors. So when you will learn CFD, you will come to know that okay, we have errors also. Now again question comes, why errors are there? Everything is in software, then why errors are there? You know, bugs are there, right? Even though we have softwares, we have bugs. So we have errors. So you can do ChatGPT and you can find out why we have errors, what kind of error we have, blah blah things. Okay, and definitely I will complete that lecture by lecture, everything I will complete. So after you should know that the way properties propagate, in same way error is also a property that also propagates. So that error can grow or error can suppress, it depends. Okay, what kind of a scheme we are using. For that particular scheme, error will grow or something will happen. Okay, then during this concept, when you will go further, then you will also come to know that we have flux limiters also. Now flux limiter, what is flux limiter? So these things will become complex, because in one lecture, if I will continue this, then you will lose the interest and it will be difficult to explain everything in short video. So I hope I have given you idea. Now understand, what is this ANSYS, what is this OpenFOAM, what is some other coding platforms, and what is this Fluent or CFX, and what is this? Okay, so see here, as a CFD engineer or as a CFD student, mainly what are you learning? Mainly you are learning that a differential equation you are going to convert into linear algebraic equation. Okay, that linear algebraic equation will behave like a formula to calculate property at any point. Clear? Okay, now in between these two things you have used CFD. So how did you use CFD, which method you have used, what kind of schemes you have used, blah blah things you are going to code. Okay, so when you are coding, you need a coding platform. You can use C, C++, Python or something, anything you can use. Okay, in that there is a popular platforms also. Actually see here, different professors, they want their students to code in different platforms. Okay, for example, in IIT Bombay, OpenFOAM is very popular. In our IITs, IIT Dharwad, people are doing in C also, C++ also, in OpenFOAM also. Like we have versatile thing, and it is good for us as the students. Like, and students are also doing in ANSYS. In ANSYS, they are doing in Fluent. Okay, I want to clear that when you are doing the coding, what do you want with the coding? You understood, right? That what will this coding do for you? Clear? And all the way you will be learning a lot of things during the lecture series. Okay, so one thing is clear. Now come to understand like what is ANSYS, what is Fluent, and why Fluent word is very popular, ANSYS word is very popular. Actually see, these platforms are already done by coding. Okay, in this actually these are the softwares, codings are already done, and they are like kind of ready-made for you. You just have to put your values, how much temperature at this wall, how much temperature at this wall. First of all, you will make your design. For example, you are making this box, and at this everything you will create. So in ANSYS, you will choose, in ANSYS you have lot of things. So ANSYS is the main software. In that you have lot of things. For example, Fluent, CFX. Come to Fluent part. According to the need of the field, like in which field you are working, you will choose. For example, thermo and fluid, Fluent is better, and for example turbo machinery problems, CFX is better. Finite element method, other things are better. So you will choose any thing, and you will start solving in that particular thing.